As we start in biological chemistry, one of the main things I want to do is make sure you know what material you need to bring along from previous chemistry classes. And the first way I want to do that is to make sure you understand what organic functional groups you need to know. You are probably familiar with the basic names of alkane and alkene, and things like alcohol and aldehyde and ketone. So I'm going to use those all throughout the semester, and you should be familiar with them and be able to recognize them. We can say that there are some that maybe your organic chemistry professors used a different name for. And for instance, the thiol group is a sulfide, sometimes in other classes, or a mercaptan group. We use the term thiol in biochemistry. And notice that a thiol is very similar to an alcohol. In fact, oxygen and sulfur are on the same column of the periodic table. And they're very similar in some ways and very different in other ways, but we're going to see both of those quite a bit through the course. So, moving on, we'll go down to the bottom of the page here. There are some groups that are going to play particularly important roles in this class, and I want to tell you a little bit more about them. I suspect you're familiar with carboxylic acid and amine from your organic chemistry class, but what's going to really play a big role here is the fact that these are acids and bases. A carboxylic acid can lose a proton, and when it does so, it becomes what we call a carboxylate. In fact, that's the way we're going to use it more often. It not only loses a proton, but it becomes negatively charged. That's really an important distinction that we're going to go over and over again a lot. Second of all, we have amines, which are bases. Notice that they have a pair of electrons on them right here. And what we can say is that as a base can pick up a proton, and that name is pretty simple. We'll call that a protonated amine. Notice that there's a real key difference there as well. Not only are we picking up a proton, but we're also gaining a positive charge. So those charge changes, the negative and the positive that we just discussed, turn out to be really very important, and much more so than you might imagine. All right, let's finish this off with three more. We have the ester, and the way an ester is going to be recognized is it has carbonyl bridging by an oxygen to another carbon over here. And so we often think about it as a COC double bond O if we're reading from right to left here. That one we're going to see much more later in the class, and we'll just be asking you to recognize it for now. Aromatic rings are those that have conjugated double bond systems. We're going to use those and see them a lot, but a lot less so than you did in organic chemistry. The last one is probably the most important one for the first month of our class. And that, do you recognize it? Sometimes our organic chemistry professors call that an amide. Us biochemists tend to call it an amide. I don't really care what you call it as long as you recognize it. And the key is that amides have a nitrogen with a free pair of electrons, but unlike the amines, this nitrogen is right next door to a carbonyl. So one thing we can say about amides that is different than amines is that that particular pair of electrons cannot pick up a proton, and it can't lose a proton. So amides or amides are never going to be charged, never positive, never negative, always neutral. And we'll be going over that in future chapters. So these are the functional groups that I want you to know. And I'm going to tell you that in lecture, one thing we're going to do is give you a short little lesson, and then we're going to have you practice something. So if you go to the top of the page, you can see here a molecule that's of biological interest and medical interest, and that's aspirin, an analgesic. And what I'd like you to do is stop the video for a moment and take a moment and go ahead and list the functional groups that you see here. Once you're done with that, start it up again and we'll go over that. Okay, I hope you've had a chance to go through that a little bit. And aspirin has an aromatic ring. It has a carboxylic acid. And lastly, it has an ester functional group. That's going to be seen here with the COC double bond O like we talked about before. So one more thing before we leave this. This molecule, as drawn, has a carboxylic acid. But remember, a carboxylic acid can give up a proton and become negatively charged. And we're going to learn in our next chapter how that can make a major difference on how this drug works in the body. So that's a good start. There are going to be homework questions for you to do on recognizing functional groups.